whiteboard this in case anybody wants to look at it later. Okay, so let's pull this up. Okay, so in looking at, maybe I can get it over here, would be really cool. You see all at once. Okay, so again, that's a UML class diagram. That's the classic way that you're going to do that. You're going to use that all through your computer science work, programming work. Okay, so at the top we have the name of the class. Second section we have the data elements or the variables of metadata. That's what each member, what each circle must know about itself. Okay. And then and the underscore means that they're hidden. You can't get to them from main without going through the methods. Okay. And then at the very bottom section, we have the functions or the methods. It's what each instance of the object can do. Okay. So again, circle is the generic circle, the idea of a circle. We can't really do anything with it. We're going to create circles based on this. Okay. In this case, we always have an underscore, and then underscore. And then in this case, we have an accessor for the radius and circle. We have a mutator for the radius and circle, which we can change. We have an area function and a circumference function. Okay. And over here, you have, let me turn on the line numbers here. Okay. Over here, we have the program for that, and it starts with the class circle. Everything inside a class circle is indented over. Okay. So again, first thing we have to have, I don't think it has to be on top, but it should be on top. Again, habits are good to form. So we're going to define this with everything has self, radius, and color. And we're just going to set the self radius, self_color. We have our accessors that just return those values for radius and color. We have the sets, which make changes. Again, we're suspending checking for values, but this probably needs to be checked to make sure it's not negative and things like that. Okay, but we're not worried about that yet. We're worried about other things. We'll come back to being worried about it. Same thing with set color. Here we have the area function. I've imported math, so I can do a math.py. You could just put 3.14 or 3.14159, whatever you want to do. And then instead of doing an exponentiation, I just did a radius times radius, but you can do whatever you want there. And then it just returns that. And then on the circumference, it's just 2 pi r. So it's 2 times pi r. Okay. And then to test it, you want to make sure you test all of the functions you've written should be tested. So I created 2 circles. I didn't really need to, but I just did. Notice that I made the second circle easy to verify the values of, and then I made the radius 1. Okay, so the numbers fall out a little easier. So remember, the init, you don't typically call it directly. I'm going to contradict that today, but in general, we don't do that on just a single class. But it's called, when we call this circle created, we're creating a new circle. Okay? So this would call init and give values to radius and color. Okay? I'm then going to use the get radius and the get color on my C1 in order to be able to print out the radius and color of the first circle. I'm then switching to C2 because the area or the radius is 1. To get the area, okay, which is pi r squared. So r is 1 squared is 1, so that should return pi, makes it easy. And then this is 2 pi r is 1, so it should be 2 times pi, which is 6 point something. This is a way to verify numbers are working, okay? So all we have left to check then is going to be the set radius and set color. So I'm printing out the initial values of C2, and I'm changing them, and I'm putting out the new values of C2. Okay. So I'm going to run that. That's what you get. Okay, and then I've changed the formatting of the numbers just so that makes sense. So that's my original one. It's a 4.5 blue, and there's the area and the circumference of the circle formatted to 2 decimal places, the dot 2f, and then I've got the original and then the change on the C2. Okay, so that's what it is we're looking for. Are there questions on that?
How would you actually set that for some object?
Yeah, you could, if you want, I would get rid of the dev name part entirely. And you can take that to like a circle.py, all lowercase letters. And you should be able to, in a new program, import circle.py, as long as it's in the same directory. That sometimes squirrely, I don't know why. For tests, you can certainly put it all in one file.
I thought it was the homework last month.
Yeah, I don't know. People have trouble. Just for the homework, just go ahead and do it, turn it in, and I'll try to figure out something. Or you can put it in the same program. You with your questions?
I'm gonna say, you didn't have to,
Was that?
you didn't have to.
You didn't have, no, I didn't specify it. That was just an extra. Okay. Other questions on this? Okay, so let's talk about the new stuff today. In this chapter, it talks about inheritance. Okay, so inheritance is a powerful tool that object-oriented programming has. It allows us to create a hierarchy of classes. Okay, so you don't have to recreate the wheel every time. Okay, so the definition here is that it allows a new class to extend an existing class. So the new class inherits the members of the class. It extends. We talk about extending a class. Okay, and the book example we're going to do here, but let's think about it conceptually first. If you're a car dealership and you're writing a program, okay, and you're going to have cars in your inventory. Okay, so the cars could have the make, the model, the mileage, so you're a used car dealer, and the price. Okay, so you make that class, you get it working, you're ready to go. Well, then you start getting some trucks in. Someone's like, well, I want to know if the truck's a two-wheel drive or a four-wheel drive. And I want to know if the cars have a number of doors. I know trucks are complicated now, but we're going to go with a simple example. So let's say that we're going to add the make, model, mileage, price, and number of doors on the car class. And the truck, we won't care about the doors, but we're going to add whether it's a four-wheel drive or a two-wheel drive. Okay, we can create those as two separate classes, and it's fine. Okay, let's say they want to add an SUV, which has different characteristics. Okay, so you take the commonalities of all these classes. They all have make, model, mileage, price. Okay, all of those have that. Okay, so we're going to make a super class called automobile. We're then going to specialize, is the word we use, that automobile into a car or a truck or an SUV. Okay, and when you do that, all the work that you do to create the automobile class automatically gets passed on to the car or the truck. Okay, so that's the concept. Okay, so let's put a new file here. Okay, to see how this is going to work. Okay. And they give a bunch of examples in the book. And this is an is-a relationship. Okay, a poodle is a dog, a car is a vehicle, a flower is a plant. Okay, and there's this idea of superclass and subclass. So if you're saying a poodle is a dog, the poodle is a subclass that inherits from dog, the superclass. Okay, and we also say that the dog is more general and the poodle is a specialization that has other characteristics. Okay, so that's the idea here. So we're going to start with our superclass. I guess you don't strictly have to, but it just seems to make more sense. It's going to be confusing if you don't. So we have a class automobile. Okay. Every class has to have its init function. But familiar, I guess it's not. I'm having a typing day. You know, days you just can't type. I try to be quick, and that just makes it worse. Okay. Everything takes a self. It's going to take a make, take a model, going to take a mileage, going to take a price. Okay. Again, your init has to set up all the variables you want your objects to have. It either has to give them a default value or it has to take a parameter and set them equal. Okay. In this case, we're going to set the values. We're setting them in as variables. So I can say a self dot underscore underscore, they're hidden, make equal to make. Again, this make refers to the variable I'm passing in. This make refers to the data attribute I'm storing in an object of type automobile. Okay. Same thing for the model. Again, mileage. Finally, for the price. When you do that. Okay. We would also have our accessors and mutators, okay? So for those all look kind of the same. So on our accessors, we have get make, okay? And it takes just the self, everything takes self. And it's going to return self dot underscore underscore make. I'm just going to do make and model in the interest of time. So we're going to get model, also takes a self. It's going to return self dot underscore underscore model. Okay, we're going to do a set make, takes a self, takes a make variable, and it looks just like the init. It's going to say self dot underscore underscore make equal to make. And we're going to do another one on a set model. Takes self and a variable we're sending in. And it's self dot underscore underscore make model. Model. Okay. Anyone lost at this point? Everybody okay? And there are others, but we're going to end it for now. Okay, so now we want to define a car class, which we want to be a specialization of automobile. Okay, so a car is a special, or we could say a car is a subclass of automobile that adds doors. Okay. So the way we start here, and this is going to vary by language, but it's fairly straightforward in Python. We're going to say class car. Okay. But I keep saying you don't put parentheses in a class because we haven't up until now, but now we do. Okay. We're going to say automobile. This is saying that a car is an automobile. It's going to inherit all the things that the automobile has. Okay. So we still need our init file, which takes self. Okay. But since a car is an automobile, it's going to have a make, a model, a mileage, and a price, in addition to the door. Okay. So all these have to go when I create a car. It doesn't know it otherwise. Okay, so I put all those things in there. We have a make, a model, mileage, price. We're also going to have a door. Okay. So for this first part, I can call, and I have to call, this constructor to make this part of it. Okay, so I'm going to package up what I can from the superclass. Okay, I do that by calling automobile dot underscore underscore init. The only time you call init directly, okay, you call of the superclass. Okay, takes a self. It's going to take of that list the make, the model, the mileage, and the price. Okay, that's all it can deal with. Okay, so it's going to create that portion of it and initialize that. Okay, but it's still a car. It's not an automobile, even though it's used. But a car is an automobile, so I guess it is. Okay, so all we have left then is to initialize the doors. Okay, so we've got the self underscore underscore doors equal to the door. And I should make the doors, and I should learn this to type doors consistently. Okay, so that's all we need to do. So we're taking what we already had. All of this, we don't have to repeat. Okay, we just have to call this. And again, this is namespace in here, in that it's the automobile, it's its init function. Okay, we're saying all this stuff. So we're going to send this part to automobile, and then we're doing just what we have left over. Okay. Once we've done this, we have access to get make, get model, and if we had typed it all in, we would also have get mileage and get price. Okay, and then we have the set make, set model. We would also have set mileage and set price. Okay, we're adding the door, and again, accessors or mutators are not universally needed. It depends on the program. Okay, but in this case, let's say we need to change that. So I'm going to create a function for the get doors. Okay, which takes a self. I'm going to return. Again, I don't have that in the automobiles. I got to put it in myself. Okay. And then finally, we have the set doors. Take the self the doors variable. And it's going to let set self dot doors equal doors. Okay. That's all we have to do. That's all that's new for us. Okay. And then we're going to have the end of the class car. Now, what the book does is to save all of this, not as automobile, but as the vehicle. Okay. So that's going to include the automobile and the car. Okay. If we wanted, we could go ahead and add the truck and the SUV. That's in the book. We're not going to, but we could. Okay. So now we can have our test function down here. We have our main. I'll make sure we call it. Okay. So in here, we're going to start by creating a car. So we can say C1 is equal to, and I can put this in here if I want, vehicle dot car. Give a name space. I don't think I need the vehicle dot like I did it before. But you can if you want. Okay. So when I create a new car, it has to have the make, has to have the model, has to be in the right order. It has to have what's next? The mileage. So what it would say. Has to have the price. Float. Okay. And has to have the number of doors. Okay. Run this now, see if we're having any issues. Why is that like that? Oh, I didn't import it. But it should be the same. Yeah, I'm not going to do that. I didn't do it before, and I don't think I should do it. If we were importing that, we would have to do that. So again, let's go over what's happening here. Okay. Of all of this code, it's going to ignore all. Well, not going to ignore. It's going to take note of all this. It knows there's now a class. There are other classes that are built in. Ant is a class, float's a class. But this is one called automobile. It knows about that now. It knows where it's located, where the definition is. Now it knows about at line 25. It knows about cars. It knows they're related to automobiles. Okay. The first line that operates or that executes is line 43. When it gets to 44, it says, okay, you want to create a car. I know where that's at. Here's the data. So it's going to go and run line 27, this car in it. And as long as it has the right stuff here, it's going to go here. This is now going to go back up and run the init at line 3. It's going to create an automobile object with the make, model, mileage, price, set all those things up. So it's going to come back here and say, well, it's not really an automobile, it's a car. That's okay. It's going to add the doors in. Right? It's going to define these two functions. They're there, but it's not going to run it. Okay? But once I have this, I can now get to any of the functions that I have done. Okay, so I can do a C1 dot get make. And even though that's not defined in cars, it is defined in automobile. And that should work, and it does. Okay. And then again, I could do a C1 dot set make and send it from a different. It won't be correct. Yeah. Okay. So if I do this, now I'm able to change the data in it. And remember, an object, it's an object. It's what we call an object, right? So we can send it to a function. We can return it from a function. We don't have to pass it as parameters in this case. We have access to it. Okay. Are there questions about this and what we're doing? and why we're doing it. Remember, this is an is-a relationship. When you're looking at the UML diagram for this, maybe wondering how you're going to put this together in a diagram. It's important to know that. It's the way that computer scientists and software engineers communicate concepts about code. You would first define your automobile class. In fact, it's in the book. There's the diagram is on page 561. You would define the automobile class with its data attributes and its methods. You would define the car class, and then you would make a line between them. The line has an open triangle that is at the bottom of the superclass. Okay? So at the bottom of the automobile, there'd be an open triangle with a line to car, and also one truck and SUV. We're doing all that. Okay. It's the open triangle that represents the is a relationship. A car is an automobile. Okay. The other way that you can put classes together, which we're not talking about yet, just so you know, is called composition, and it's a has-a relationship. Okay. In that case, it's a black, I think it's a black diamond that you put there. I don't quite remember in the UML diagram, but it's filled in some way. A has-a would be something like a car has an engine. Okay, they're not separate. They're the components of the class. And in that case, all you do to implement it in code is basically one of the member data of your class is another instance of the class. Okay. So that's the basic idea behind inheritance. There's a good example here in the book on the Endless Spotlight section, starting on page 561, where we're creating an account class, a savings account class, and then we're creating a CD class, which is a specialization of the savings account class. Okay. So whenever you're looking at code, you want to know, well, if I was going to turn this into a UML diagram, well, it's called savings account. What member data does it have? Well, it's there I'm on page 562. It's on pages 10 through 12. Okay. There's an account number, there's an interest rate, and there's a balance. All those are hidden. Okay. So we know that's what's there. And then the methods we have are the set account, set interest, set balance, the get account, get interest rate, and get balance. Okay. On the next page, when we're doing the class CD that inherits from savings account, okay, we call in line 50 there, so it's all in one code, one program called accounts.py. Line 50, we're calling the savings account initialization program, or the constructor. Okay. And what we're adding to that is the maturity date. So we have a initialization there in our program. We're also doing a set and a get on that maturity date. Okay. What's next on page 564 is a demo of putting all that together by importing the accounts program and going through that process. Okay. Since there's no additional homework this week, it's a good idea to type that out, type it all out, make sure it works. Okay. Having one working example can be super helpful when it comes time to do the homework. Okay. Any questions about any of that stuff? Okay. Are we doing okay with objects? The test is not far off. It's a good time. We've got 10 minutes in class. I must have gone faster than I did this morning. Okay. I will answer any questions about objects that you have and about inheritance. If you're still iffy on the whys of inheritance or the whys of objects, let's talk about it. If you're iffy on why you would have inheritance, I think if you understand objects, then inheritance seems like a simpler concept. Right? But if you're still iffy on objects, then we should talk about it. Any questions on anything at all?
Will you take off points if we don't figure out how to import the class file and do it in the same function thing?
So what I would prefer, put it in the same program so it works, rather than it not working. But yeah, no, that's.
Because I know in like C++, you wanted us to have like separate files for the.
Yeah. Yeah, we'll eventually want to get there, but right now, I mean, it's the same thing. If you and you should, but I'm not going to make you do it at this point. You should be verifying all the input. You should be doing the try catch, all that stuff. But let's get the objects first. Okay, so let's focus on that. So I'm suspending the requirement that you have to do all that testing now. You know, in this program, a car can't have 0 doors. I wouldn't imagine. A car can't have 1,000 doors. So you want to put some restrictions on that. Okay. Things like that. Okay. The mileage can't be less than 0. But again, I'm not expecting that yet. So focus on the objects and assume that the user is always going to give you good data, which is a bad assumption. Okay.
So about that, about the, I know you're not doing it right now. But,
Yep.
Input verification for classes,
Yes.
would the verification blocks and lines be in the main or in the class?
Yeah, it should be when you're doing, that's the whole point of having mutator functions, is that you can set the rules. Okay. So in this class, if I were going to implement something reasonable here, where I'm setting indoors, okay, if you put it here, you know, if doors are less than 0, or doors, how many doors can a car have? 5? 4?
About 6.
You just have to decide. Let's say it shouldn't be greater than 10 in any case. Okay. Then you would have to do some error message. Okay, but you do it here. So, or even if something up here with like the mileage. Okay, if you're going to test whether the mileage is legit or not, you would go ahead and in the, I'm not doing that one, but in the set mileage, you would make sure that it's not less than 0. Okay, and then whatever happens to that class, wherever it gets subclassed or whatever, you're still controlling what happens. Okay, that doesn't mean that you shouldn't also in your program, when you're asking for input, check it there too. You can't check things too many times. Okay, so that's called defense in depth. Okay, every time. So if the program you're writing that uses this class, make sure that the data is good, and then your class double checks it. That's better than nobody checks. Okay, especially if you're not designing your own classes. Okay. Other questions? Okay, that's it. I have a question for you, Chief. Now that I'm done with Squid Game, what am I going to watch now?
Well, if you like Samuel Bronson, I recommend you watch this one video called
Goblin? You're my source for Korean entertainment. So you know. You know, it's a Korean talk. I've been working for Johnson. It's a Korean taco restaurant. Yeah, pretty good. But the people, I think they are actually pretty good. All the Asian restaurants in Johnson City are the people. Okay. But it's okay. There's also a Japanese one I watched. I started watching. It's similar in that it's oh, is it? I might be awesome. Oh, could be. Is that Japanese? Yes. Yeah, that's what. Yeah. It's the one with the cards. Yes. Yes. Yeah, I feel like that. Yes.
Office.
Well, actually, no. I'll be out at 12:30. Yeah, we're right now.
Well, I just want to talk about the office.
Okay, can you do it 12:30? How about at 12:32? Not 14. Okay. Okay. I can't. Yeah,
It's because I usually do inputs so I can look at it myself and have how many iterations I want to do for it.
right.
So I really don't have a need for mutator after the. So I kind of like lost how exactly it works, I guess.
Okay, if you want to go back and change data,
Yeah.
they get stored in your class, updated. It's like the car thing with price.
Yeah.
So if you want to change that, you can't do it directly because it makes it hit.
Yeah.
So you have to have a mutator function.
Okay.
To be able to get to it. And any kind of, you don't have a price less than 0. So, you know, you can do all the checks in that function.
Okay, cool.
But it allows you to change it after it's created. Gotcha. What if the demo, we're gonna put the self there, and then you don't have to pass a read, it's already knows. Okay, so, whatever the name of the circle is. And so that would create, it's called circle dot area, or circle one dot area. Remember that. Okay, so circle one dot area. So we'll just go through that class and find that. If that was. Yeah, you just go to right above. Still around? Yeah, it's indented here, and it just takes self, because it can get to radius, okay? So when you call it, you just call it based on. Do I have to print it out like that? Yes. Okay. Because, I mean, or you can do something with it if you want. I mean, this is going to return a float. So you could say area is equal to C2 dot area. Now we've got it. So you have to call that function as a part of the object, or part of the class. That's C2. So we're making the C2. Yep, we don't have to worry about the call that. No, right. Yeah. Yeah. Yeah, send me an email if I forget, but I'll try to remember to do that. Yep.